Hello everyone, myself Akansh Reddy from St. College of Engineering, Bangalore, and my USN is 1VE22IS006. Today we'll learn about static caching, and the contents are introduction to static caching operations, index mapping, collision handling, advantages and disadvantages, loading factor and rehashing, and applications of static caching. Introduction. Davy decimal classification has worked done well in libraries for many, and the underlying concepts work just as well as in computer science. Software engineers can both file space and time by shrinking the original data assets and input strings to short alphanumeric hash keys. When someone is looking for an item on data map, hashing helps narrow down the search. In this scenario, hash codes generate an index to store values. So here, hashing is used to index and retrieve information from a database because it helps accelerate the process. It is much easier to find an item using its shorter hashed key than its original value. Static hashing refers to an hashing technique that allows users to execute lookups on a dictionary set that has been finalized. All objects present in the dictionary are final and do not change. Static hashing is often used in database and other applications where data is not expected to change frequently. It is also used in some cases where the data is expected to change frequently, but the cost of changing hash function is too high. Static hash operations. First one, search a record. Second one, insert a record. Third one, delete a record. And fourth one, update a record. Search a record. In static hashing, the function key always generates the same bucket address. For example, if we have a data record for employee ID 107, then the hash function modify which hash into x of 5%, where x is the ID, then the operation will take place like this. H of 106 percentage modulus 5 is 1. That indicates that data should be stored in the place or searched in the first bucket in the hash table. Insert a record. If the bucket is already full, you need to use a collision resolution strategy. There are many different collision resolution strategies, such as linear probing, quadratic probing, and chaining. This function will calculate the hash code of the key, then it will locate the bucket in the hash table that corresponds to the hash code. If the bucket is empty, the function will insert the record into the bucket. If the bucket is already full, then the function will use linear probing to find an empty bucket. Delete a record. Delete a record in the hash data structure. You need to follow these steps. First one, find the record you want to delete. This can be done by using hash function to find the bucket where the record is stored. Second, remove the record from the bucket. If the bucket is using separate chaining, you need to simply remove the record from the linked list. If the bucket is using linear probing, you need to mark the slot as empty and then move all the records that are after deleted record one slot forward. Rehash the table. This is necessary to ensure that the table remains balanced. It is important to note that deleting a record from the hash table can cause the table to become unbalanced. Update a record. To update a record, we'll first search it using a hash function and then record is updated. If you want to insert some new record into the file, but the address of a data bucket generated by the hash function is not empty, or the data already exists in that address. This function is in the static caching is known as bucket overflow. This is a crucial situation in this method. Second, and we'll learn about open hashing. When hash function generates any address that already contains data, then the next bucket is assigned to it. And then this process is called linear probing. For instance, if R3 is a new address that needs to be entered, then the hash function will generate 112 R3 address. However, the address is not produced is already full. As a result, the system selects 113 as next level data bucket and assigns R3 to it. Close hashing. When a data bucket is filled, a new one is created for the every hash result and then connected after the old one. This method is known as overflow chaining. For example, if R3 is a new address, then the hash to be added to the database. The hash function will assign its address 110. However, this bucket is too full to accommodate the additional data. In this scenario, a new bucket is placed and linked to the end of 110 buckets. Index mapping or trivial hashing with negatives allowed. Index mapping, also known as trivial hashing, is a simple form of hashing where the data is directly mapped to an index table in the hash table. The hash function used in this method is typically the identity function, which maps the input data itself. In this case, the key data is used as an index in the hash table, and the value is stored to that index. For example, if you have a hash table size of 10, and we want to store the value of apple with the key A, then the trivial hashing function simply map the key A to the index of A in the hash table and store the value of apple in that index. Collision and its handling. What is collision? Since the hash function gets a small number of keys which has bigger integer string, then there is a probability that the two key results are the same value. This situation where a newly inserted key map already occupies the slot in the hash table. This is known as collision, and it must be handled using some collision handling techniques. What are the chances of collision with large table? Collisions are very likely if the table is very big and has to store large amount of keys. An important observation is birthday paradox. With only 23%, the probability of two people having same birthday is 50%. And how to handle collisions? There are mainly two methods to handle the collision. Separate hashing, open hashing. Today we will learn about open hashing. Separate hashing. The data behind the separate chaining is implemented array to the linked list to a chain. Separate chaining is also one of the most popular and common used technique in order to handle collisions. The linked list data structure is used to implement this technique. So what happens is when multiple elements are hashed into the same slot index, then these elements are inserted into a singly linked list, which is known as chain. Here are those elements that hash into the same slot index and are inserted into a linked list. Now we can use a key K to search the linked list by just linearly traversing. If we intersect key for any entry is equal to K, then it means that we have found our entry. If we have reached the end of a linked list and yet we haven't found our entry, then it means that the entry does not exist. Hence, the conclusion is that in separate chaining, it is also known that all the elements are connected to each other. Advantages and disadvantages. Advantages. As it is simple to implement, as table never fills up and we can always add more and more elements to the chain. Less and as table is less sensitive and as more as function and load factors. Is mostly used when unknown how many and how frequently keys may be inserted or deleted. The disadvantages. The cache performance of chaining is not good as keys are stored using a linked list. Open addressing provides a better cache performance as everything is stored in the same table. And it is also waste of space. Some part of hash table are never used. If the chain becomes long, then the search time can become into the power of n in the worst case. And uses extra space for links. Double hashing. Double hashing is a collision resolution technique which is used in the hash table by working off two hash functions to complete two different hash values for a given key. The first function is used to compute initial hash value. And the second hash function is used to compute the step size of the probable sequence. Double hashing has the ability to have a low collision rate, as it seems two hash functions to compute the hash value and then step size. This means that the probability of collision occurring is lower than other collision resolution techniques, such as linear probing or quadratic probing. However, double hashing has a few drawbacks. First, it requires use of two hash functions, which can increase the computational complexity of the insertion and search operations. Second, it requires a good choice of hash functions to achieve a good performance. The hash functions are not well designed, then the collision rate may still be high. Load factor and rehashing. The load factor in the hashing is a measured flow of how the hash table is, and it is used to calculate it by driving the number of elements in the hash table by size of the hash table. A higher load of factor means that the hash table is more full and low load factor. That means that the hash table is less full. The load factor is an important factor to consider when choosing an hash function. A good hash function will distribute the elements evenly throughout the hash table, and which helps to keep the load factor low. If the load factor is too high, then the collisions are more likely to occur. Collisions happen when two or more elements are mapped to the same location in the hash table. This can lead to the slower retrieval times as algorithm has to search through the linked list of elements that are stored at that location. Rehashing. Rehashing is a process of increasing the size of the hash map and redistributing the elements to a new bucket based on the new hash values. It is done to improve the performance of hash map and prevent collision caused by high load factor. When the hash map becomes full, the load factor increases. As load factor increases, the number of collisions also increases, which can lead to the poor performance. To avoid this, the hash map can be resized and the elements can be rehashed to new buckets, which decreases the load factor and reduces the number of collisions. Applications of static hashing. It is used in database indexing. Hashing is used to efficiently index and retrieve data in database and other storage systems. It is used in password storage. Hashing is used to store passwords securely by applying a hash function to the password and the storing hash result. Data structures. Hash is used in the data structure such as hash table for a quick search and insertion, and it is used in quick access data. Static hashing is used for applications where quick access to is required and the amount of data stored is advanced. Static hashing requires that database has objects and refers remain the same. This means that the applications are limited and the database which contains information which stand rarely are also eligible. Thank you.